Welcome to 5.3 Sum and Difference Identities for Cosine. We're going to do a couple more examples to wrap up this lesson. So the example 5 is true or false. Cosine of 11 pi over 12 cosine pi over 4 plus sine 11 pi over 12 sine pi over 4. And we want to know, does that equal -1/2? So this is a great time to pause, try and see if there's a connection to any of the cosine sum and difference identities. So let's take a look what we might notice. So one thing you might observe is that the cosine and the sine of pi over 4, those are values we could find exact values for. But what I'm hoping you see is if you back up and you look at the left-hand side as a whole, you might notice that we have a cosine, cosine, sine, sine, an A here, an A here, and a B there. So, and then this is a plus. So because we have this cosine, cosine, sine, sine, and these first two angles are the same in each term, and the second two angles are the same in each term, then we are looking at one of these. So because it's a positive, then that's going to be a cosine of an A minus B. So this orange right here is really showing us that this is going to give us the cosine of A minus B. So now if we return back to the original, we could rewrite this as a cosine of one angle minus another angle. So one thing you might want to notice is the connection. So here, A is going to be that 11 pi over 12, and B is the pi over 4. And you can see that same consistency where A is 11 pi over 12 and B is pi over 4. So therefore, plugging those values into the cosine of A minus B, we can put cosine of 11 pi over 12 minus pi over 4. I'll take this calculation over to the side. So 11 pi over 12 minus pi over 4. To add and subtract fractions, we need a common denominator. So in this case, the denominator will be 12. The top already has the denominator of 12, but on the bottom, we'll multiply top and bottom by 3 to get that 3 pi over 12. Now we can subtract. So we get 8 pi, the denominator stays the same at 12. So reduce 8 pi over 12 by 4, and we get 2 pi over 3. So this is really the same as cosine of 2 pi over 3. Now, what do you notice about 2 pi over 3? That is a special angle. So here, if we think of this as 3 pi over 3, then we're going to be here with pi over 3 as our reference angle, or 60 degrees. So here the cosine is -1/2. Of course, you could also go to degrees as well. So that would be 120 degrees, and with that reference angle of 60 degrees. So either way, we get the cosine is -1/2, which is what the equation states. So since the left-hand side actually equals -1/2, it means this is true. Example 6, verify secant of pi plus x equals negative secant x. Let's start with the left-hand side. We do not have an identity about secant of a plus b. However, we do have a cosine identity for cosine of a plus b. So let's rewrite the secant in terms of cosine. Now that we have this written in terms of cosine, we are now able to apply the cosine of a sum identity. So on the bottom, we'll get couscous. So cosine A, cosine B, minus sine A and sine B. And then remember, the angle order will stay the same. So it's pi x pi x, pi x. Now we need to find the values for cosine of pi and sine of pi. Those are quadrantal angles, so we will just use the coordinates -1, 0. So we get cosine pi is -1 and sine of pi is 0. I like to write out the four quantities. And now we have cosine of pi is -1 and sine of pi is 0. And then because we do not know what x is, we don't know what cosine or sine of x is. So we just put cosine x, sine x. Now we simplify. -1 times cosine x is negative cosine x. 0 times sine x is just 0. So we end up getting 1 over negative cosine x, and this is in fact negative secant x, which is our right-hand side. I hope you enjoyed the video. See you next time.